Good morning, everybody, or good afternoon, shall I say. It's morning for me, but afternoon for you guys. Welcome to the fourth HDR seminar series session. We have today our Vice President of the Engineering HDR Committee, Joelle, and she will be giving a presentation on the following: predicting corrosion for future aircraft structural prognostics and health management. Joelle, do you want to take it away now? And I will mute myself and be in the chat with you guys, all right?
Yep, sure. Thanks, Cody. My name is Joelle Chia, and I'm supervised by Wim Verhagen, who is an associate professor in aerospace engineering and aviation. My co-supervisors are Jose Silva, who is also in aerospace, and Dr. Ivan Cole. I think he's in mechanical manufacturing and mechatronics. So before I start, I just want to do a little bit of advertisement. So most of you should have received an email from Selena earlier this week about an IATA airline management challenge. This challenge involves simulating an airline business and competing with other universities around the world for the most profitable simulated airline business. Each university can only have one representing team of a minimum of 4 and a maximum of 10 students. So if you are interested, please reach out to me by Teams or email. I am coordinating the team for this challenge, and we'll need to submit the names by next week. So all right, I'll start with my presentation for this seminar. Firstly, we'll start with a little bit of polling. So if you could go into menti.com and use this code 63024800, or you just scan this QR code, go ahead to answer this question. What words come to your mind when you hear the term corrosion? We'll give it about a minute or two and see what responses we have around here. That explosion. That's a good one. Abrasion, yes. Abrasion do lead to corrosion, and sometimes corrosion also lead to abrasion. Rust, definitely. So rust is a special kind of corrosion that is caused by iron being oxidized. Any sources of oxygen could lead to the iron being rusting. And that's probably one of the most common form of corrosion that we see in our everyday lives as well. So yeah, basically corrosion, I actually don't know. Yep, so I'll explain a little bit about corrosion, specifically atmospheric corrosion. So corrosion happens when some salts or some chemicals in the atmosphere, in the environment, come into contact with metallic structures or metallic materials, and it leads to degradation of the metallic layers. So any kind of metals, they have different kind of layers in their materials. And when that material degrades, that's corrosion, which means that material is being damaged and exactly deterioration of metals. So it can occur anytime. It can occur very quickly. It can occur very slowly, depending on how corrosive that atmosphere is, the environment. And yeah, so this can also occur to any kind of metallic structures, including silver structures, the bridge, your car, your computers, as well as aircraft. So from the aviation industry perspectives, most aircraft owners, operators, and mechanics are also not corrosion experts. So they have no idea what is corrosion, but they see it happening on the aircraft. And what concerns them mostly is the cost of having to repair the metallic structures due to corrosion, and the time it takes, as well as safety concerns, because when the metallic structures of the aircraft degrade, it could lead to aircraft accidents. And that has happened a number of times before over the past 30 years in aviation history. So we go on to another question. In this question, I would like to hear your thoughts on what you think can be done to minimize corrosion on aircraft structures. Use of better materials, yes, in terms of having redesigning, for example, now aircraft are going more towards composite structures that are less prone to corrosion. So that's one part of it. Test materials for the long term. Yes and no, because as I said, corrosion can happen in a very short time depending on how corrosive the environment is. So even if you test the materials for the long term, there could be conditions that you are not able to test upfront, which leads to the material degrading due to corrosion in the short term. Make them of plastics. Plastics for an aircraft, it's not very feasible, I would say. But yeah, composite structures would be the next more feasible type of material. Coating of the metals, yes, using corrosion protection coatings on the metallic structures. That's a very good one. But then again, even now, aircraft structures are being coated with corrosion preventive compounds, but as the aircraft operates, sometimes the coatings get scratched or coatings deteriorate. So eventually the material under the coatings will still be prone to corrosion. Maintenance and inspection, yes, definitely. And that's the main topic that I'm going to discuss about today. So we'll move on to the next slide. So one of the methods to minimize corrosion is to predict when and where it is happening so that you can implement predictive maintenance and inspection before the structure fails. So corrosion prediction models have been developed over the past few decades. And this review that I reference here goes into more details on those established corrosion prediction models. But the limitation is that these models are mostly based on long-term cumulative exposure, and they assume that the microclimate and the development of corrosion are in a steady state that averages out over the long-term period. And unfortunately, that would not apply to an aircraft because an aircraft is a very mobile machine that is constantly exposed to different environmental and operational conditions. So we can safely assume that the microclimate and the development of corrosion will be quite variable. And also taking on this assumption, the Australian Defence Force developed a corrosion prediction system in their military aircraft by instrumenting the aircraft with environmental and corrosion sensors. But the problem here is that whatever that applies to the defense or military aircraft is not transferable to a civilian aircraft like the commercial aircraft that airlines operate, or like the private jets or even smaller training aircraft like this one over here. Firstly, they belong to different regulatory bodies, so different regulations and certifications apply. And secondly, which is the most important factor, is that civilian aircraft are more sensitive to weight additions. So that is to say, if we add sensors onto this sort of aircraft, that's adding more weight, which is more payload, and that translates to even higher operating costs. So at this point, the airlines or the aircraft owners would say that's too much trouble. They will just continue washing and inspecting their aircraft for corrosion, and then we're back to square one. So drawing from the identified research gaps, my research integrates the essence of corrosion models, actual operating environment parameters, both in flight and on ground, into an airframe corrosion digital twin. The objectives of my research will be to use an appropriate corrosivity estimation model, which will be defined along the way to estimate the corrosion exposure in aircraft structures during its operational life. And to accomplish this, I will be using actual in-flight and ground environmental and operational parameters. Then next, I will develop a prediction model to predict the location and severity of corrosion damages based on the aircraft's operating environment. And then finally, I will develop a unified airframe digital twin with a simulation environment that can support proactive corrosion control and management. So the purpose of integrating the airframe digital twin is also to enable real-time monitoring and prediction. So from these objectives, my research will address three main research questions. And all of these are according to the objectives formulated here. And there are certain boundaries within my research where the research is scoped around the application on general aviation aircraft. So for example, flight training aircraft, in which case I have also engaged with the Aviation Academy in our university to obtain actual aircraft data to work on. This research will also only account for atmospheric corrosion in aircraft structural damages, which means we will assume that all damage references used in the dataset are only due to atmospheric corrosion and not contributed by other factors such as fatigue or other operational events. And finally, we also want to assume that coatings are damaged upon operations, so we will disregard coating degradation for simplicity. So in terms of methodologies, in my research, since I am focusing on predicting atmospheric corrosion on the external surfaces of aircraft, yeah. So atmospheric corrosion refers to the corrosion that is caused by the interaction of the material with its environment, which is, for example, temperature, relative humidity, how wet the atmosphere is, and the presence and concentration of corrosive salts. So my first step is to answer the first research question, which is to model the varying environmental and operational conditions in a time series. I am using the flight data from the aircraft's existing flight instrument systems to obtain the geographical coordinates of the aircraft and the operational conditions such as altitude, accelerations, and airspeed over time. And then for environmental parameters such as temperature and relative humidity, I use weather data collected from the Bureau of Meteorology weather stations that are closest to the aircraft at each time. So combining them, we have both spatial and temporal information about the aircraft's operating environment, which we can use to plot into a map, such as shown here, to understand where the aircraft has been to and what those conditions were during those times. Next, to investigate research question 2, I collect samples from the aircraft external surfaces by using a regular cotton pad to swab the defined surfaces. And then these samples are put through ion chromatography and inductively coupled plasma mass spectrometry, in short ICP-MS, which are used to detect and measure concentration of certain ions. And then from there, we can analyze the amount of chlorides and sulfates deposited on the surfaces and compare that with the flight path and operating environment to develop this time series corrosion prediction model using machine learning algorithm. In the later part of my candidature, I will also be conducting experimental studies to examine how an aircraft structure is corroding in a corrosion chamber by exposing the specimens to varying environmental conditions, similar to what the airframe experiences. Now, to address research question 3, we need to first understand what is an airframe digital twin. So this is a review article that I published with my supervisors last year, discusses what an airframe digital twin is and how it can shape the future of the civil aviation industry. In short, an airframe digital twin is a virtual representation of an individual aircraft and all of its structures, basically the skin and bones, and used for lifecycle management, including virtual manufacturing and testing, damage diagnosis and prognosis, remaining useful life prediction, and so on. The digital twin is not a new concept in general, and it's certainly not in the aerospace context as well. But in aerospace, it has mainly been applied towards defense aircraft and focuses mainly on structural fatigue damages, stress, and cracks. So in my work, I aim to extend the airframe digital twin to corrosion so that the operator or the mechanic can predict when corrosion is likely to occur and implement predictive maintenance measures. And then beyond my research in this PhD, future work can also couple airframe corrosion digital twin with existing fatigue digital twins to extend that coverage of aircraft structural prognostics and health management. Oops, sorry. So this is what is shown here is a screenshot of a web page of the digital twin that I developed. It's a 2D map-based digital twin. So right here is a spatial temporal map that tracks the aircraft's historical and latest operating environment. Because as introduced earlier, our varying environmental and operational condition consists of both spatial and temporal data. And then right here, a user can define the time window that they want to look at, and the digital tool that is connected to a backend machine learning prediction model will show the user the predicted corrosivity over the defined time window period. What's more is that not only can the user use this digital tool to look at historical states, they can also simulate a future scenario by defining, for example, the next 1 week of flight operations, and the model will also be able to tell the user how the aircraft might possibly be exposed to any corrosive environments and the extent of corrosivity. This can help the user make decisions on certain flight paths or predict the necessary maintenance if required. So that comes to the end of my presentation, but before we conclude, here's one last QR code to connect on LinkedIn. And again, if you are interested in the IATA Airline Management Challenge, email me or message me on Teams or LinkedIn, and I will connect you with our team. And finally, I hope this session was informative. And if you have any questions, you can put in the chat or unmute yourself.
I was just going to give a couple of minutes for questions as well. If you guys want to pop it in the chat or take off your mics, I will be also happy to read out your questions. But really well done, Joelle. I really enjoyed that presentation, and thank you for making it so interactive. I definitely do hope that you guys, I'm sorry, thank you. I definitely do hope that you guys add her on LinkedIn. She's very active and a really big part of our engineering HDR community. Hopefully you guys can hear me okay. Yeah, if you guys have any questions, now would be a great time to ask her. If not, she's very active on email as well, so she'll definitely get back to you. I'm just going to post a link to the IA TA challenge here again, only because some people might not have seen it. And it's a really great opportunity that our Associate Dean HDR wants to promote because she is a part of aviation and aerospace engineering, but you don't have to be part of that department to sign up, because we definitely welcome as much collaboration between the departments as possible. So if you leave here with nothing besides Joelle's very informative chat and session, please definitely have a look at this link. Any questions?
Can I ask you a question? Thank you, Joel. It was a very informative talk. I just missed it, I guess. When you make the predictions using the machine learning model, are you getting the weather data from outside, or are you making this like a prediction based on the historical based on the previous days, or I don't know?
Yeah,
This kind
so
of
it's a time series machine learning model. So for example, I'm trying with a couple of different algorithms like XGBoost, LSTM, things like that. So basic time series. So it will take historical, environmental, and operational parameters in the time series to predict the next couple of the next few time window of the continuous time series and predict that exact values out. Does that answer your question, Onika?
Yeah. Just thank you.
All right, thank you. Thanks for the question.
I also have another question, although this might be more relevant to the not technical, but the procurement side of things. Did you ever end up getting that equipment that you really needed?
No. So yeah, so previously I was talking about having an experimental part to it, and that is the part of the instrument that I really require in order to carry out the experiment. Right now, in terms of procurement, it's still in process, and we don't have any existing instruments in RMIT to do the experiment. So I've also connected with a couple of universities overseas that has the instrument, and potentially I could either have them to do it for me, or I can go over there to do it by myself. So yeah, also shout out to everyone here. If you're looking to do like things that are not available in RMIT, reach out to connections and get some collaborations with other university partners or other institutions, and that can really enrich your overall PhD experience as well.
Some really good advice there. I'm really glad I asked that question now. I didn't know that you actually ended up reaching out to them. That's really good that you managed to find something, because RMIT has a lot of stuff, but we don't have everything. And especially in the short span of X amount of months that you need to complete a project in. And if it's such a technical issue and you need a machine to do it, definitely feel free to reach out. Thanks. And good on you, Joelle. That was really good.
Thank you.
All right. Does anyone else have any questions? If not, I will be turning off the recording. And I just want to thank Joelle today for her presentation, and thank everyone else for attending as well. Please feel free to reach out. I saw some people already like the link for Airline Management Challenge. So hopefully they will be in touch with you soon, Joelle.
Yep, I hope so. Thanks, Cody. Thanks, everyone.
Thanks, everyone. Have a good one.